example, let me just filter a few here. Oh, that's a specific area. So, for example, I have this guy here is accessing Facebook, blah, blah, blah. You can be able to get the details here. Let me not show you this one. It can be classified a little bit. Yeah, but get used to what I'm showing you. So, the graphical user interface, as you're seeing here, can be able to manage your network a little bit better. Okay, you can be able to tell where there are problems. Maybe the red can mean that we have an alarm. You need to respond to these alarms. And that is all about network management. So network management comes in to provide monitoring and configuration. You can also configure devices using these interfaces that I've just shown you. Okay, so you can configure multiple devices at the same time. Maybe you have several switches or several routers that need to have their routing policy changed. Then you can change that within a click of a button. And then, excuse me. Then we are going to look at technologies that can be used to support network monitoring, network management, and also network automation. You can automate your network so that whenever there are faults or there are certain problems, certain known problems, the network can actually heal on itself. Okay, yeah. So you can come up with scripts and then run them through the network management platforms. And these scripts can be used now to automate your network management. Assuming you would like to save, or rather you would like to back up all these configurations. Okay, you like to back up all these configurations every day. So instead of running backups manually before you leave for home, you can actually automate that. How do you do that? We come up with scripts. And the popular programming language for this is Python. Okay, so we're going to be tested on a little bit of how to run Python scripts, how these scripts are written. So I expect a little bit of some questions about Python programming. And we are going to look at protocols like netconf. Netconf is a protocol that is used now to send configurations to a switch. Assuming you want to run a particular update on the configuration on a particular switch. So netconf can come in as a protocol that can be used now to interface between the switch and the manager. Okay. Yeah. The network manager can be configured to run that protocol in order for it to be able to send configurations to a network switch or to a network device. Okay. Yeah. We are going to look at other advanced technologies that are also used in network management and monitoring and automation. And that is, we're going to have Yang. Okay. Yang stands for yet another next generation language. So Yang is a modeling language, which is used now to model certain services. Okay. So we use it especially when you're modeling. Maybe you're modeling SSH configuration. So maybe you're modeling maybe something like DHCP. So we use it to model the script. Once you create the Python script, use Yang now to model the file that will be used now to install these scripts, or rather to configure this device using the scripts that we've come up with. Okay. Then we have another protocol we call telemetry. Now, telemetry works similarly with another protocol called SNMP. SNMP. So SNMP is a traditional protocol which is used now to monitor devices, especially for monitoring. It is used to get the real-time status of devices. Assuming you have a monitoring tool that you're using to check the physical status of your switches, or maybe the physical status of your devices. So SNMP can be used to send SNMP packets to these switches or these devices in order to get the uptime, or rather to check whether these devices are running. Okay. So assuming these are devices that are in different building blocks within your organization, and you want to have a dashboard so that anytime you're seated in your office, you can be able to tell whenever there are faults within these devices. Maybe sometimes you can realize that a particular switch has gone off and you are not aware. And you are just being called by the user to be notified that hii switch yetu ni kama network yetu ilizimika kitambo. So in some organizations, there is no such kind of carelessness. For instance, in an ISP network, if you let the customer call you to tell you that they do not have internet, then you're going to lose that customer, right? So you put a team of support officers who monitor, who look at, who stare at these dashboards on a daily basis in order to ensure that no customer is going to report that their internet went down. Okay, yeah. So network management is one of the areas that we are going to be looking at in our discussions. And then we're going to look at the Huawei scenario, specific scenario where we're going to look at Huawei Cloud Campus solutions that are used to provide all these services that you have just mentioned. Okay, yeah, and we're going to look at how the Huawei solutions like iMaster NCE Fabric, iMaster NCE Campus, and iMaster NCE SD1 solutions are used to provide support for different technologies within the Datacom portfolio. Okay, so that is Datacom. Okay, yeah, so we're going to cover all that, and I've said, as you've seen, this is a lot of content. I will expect you at some point to be covering some on your own. Okay, yeah. Let's look at data center networking. Data center networking does not carry much. You're actually going to get very few questions. This is going to cover 20%. So at data center, we're going to expect you to have an understanding of what is an MLAG. This one is a type of link aggregation, which is used on data centers. It's achieved especially when the data center is managed using the Huawei cloud solutions like iMaster NCE. So these ones you don't configure manually. It's something that is controlled by a controller. So the iMaster NCE works as the SDN controller in order to deploy this kind of MLAG. Okay. Then we have VXLANs, which I've also mentioned in routing, in VPN technologies. So VXLAN is a protocol that is used to extend the virtual local area network through the internet. So it acts as the overlay. So remember I said we have an overlay network and an underlay network. So on the overlay, we run VXLAN, and on the underlay, we run EVPN. EVPN is another name for BGP, MPLS, IP VPN. All right. So these ones use BGP. So when you're configuring these technologies, we're going to involve BGP and MPLS. Okay, that's how we give them these names: Ethernet, VPN. Okay, so we're going to look at the concept of microsegmentation and other technical aspects that are related to EVPN technologies. Then we're going to look at advanced data center networking technologies and applications, where we're going to talk of computing aspects of a data center. We're going to look at storage aspects of a data center. Okay. Yeah. Remember, a data center will support things like computing power, will provide storage power, and what other services are provided in a data center? Security, okay, yeah, and others. So in a data center, we're going to look at the concept of virtualization. So we're going to look at OpenStack. OpenStack will not be tested. I'm sorry, so will not be tested. You are lucky. But for your own general knowledge, you can also have a look at what is OpenStack and how to deploy OpenStack, and also set up the network for connecting different components of OpenStack. OpenStack comes in different components. I think at this competition, we have not had questions that really talk of how it's deployed and stuff like that. You're lucky that we are not asked these questions, but they will be asking very basic knowledge on how OpenStack works. Just have a little knowledge about OpenStack. So we're going to look at server virtualization and network virtualization. Okay. Yeah. Technologies. And we're also going to look at storage technologies and where we can apply these technologies on real data centers. Then once we're done with that, we're going to look at the Huawei Cloud Fabric solution. So the Cloud Fabric we're going to be referring here is iMaster NCE Fabric. So we're going to see how iMaster NC Fabric is used for hosting and computing. We're going to have a look at how services are deployed and how services are orchestrated. So we're going to look at service deployment and service orchestration on data centers. Then we're going to look at the cloud network integration and container network deployment. Okay. So in cloud computing, we normally refer or rather talk of some technologies like containerization. Okay. And you probably have heard of concepts like Docker. This is how to manage containers. So we're going to discuss some of these principles there, and also how to deploy multi-cloud environment. Assuming you have different data centers in different locations, and you need to connect them together for purposes of extending the service, we're going to discuss that. And the concept of supercomputing, where we're going to look at some of the principles of supercomputing. Then we're going to look at data center security solution. This is another area we're going to be discussing on how to protect our data centers, how to design security as well. And then we're going to look at planning and design, how to plan general data center network solutions, and also how to plan the architecture design, data planning for the underlay network and the overlay network, okay, and also how to plan for the multi-cloud and multi-DC network design. And lastly, we're going to look at DCN operations and management solution. This one is like how to support data center networking. So we're going to look at knowledge on how to manage data centers. That is operations and management. How you as the data center engineer will be managing the data center, or the data centers in a multi-cloud environment. Next, we're going to be looking at security. Someone has a question. I think talking of being examined at national finals as groups of 3 per group. No. National finals, you'll be taking the exam alone. Regional finals is where you're going to be grouped. Kelvin, you're okay with that? Okay. Security. So we're going to look at the whole life cycle of information security. Not everything, but slightly a little bit of information security basics. This is something that you can actually read on yourself. The common cybersecurity threats that we know. And then we're going to look at information security management technologies. So this one I will expect you to master. I will share some of these notes so that you look at them as we continue. Then we have cybersecurity basics. You'll need to have a general understanding on basic firewall technologies, including security policy, how to configure security policy, how to configure a NAT policy on a firewall. Basically, we will be looking at how to protect our networks using firewalls. So we are not going to look at the whole life cycle of network security, but a portion of it. That is how to manage firewalls for different security operations. Okay. Yeah. I've said we are not going to look at the whole life cycle of information security, but we are going to be specific on how security firewalls are used to provide different security operations. Okay. Yeah. So these security operations include VPN technologies, how to configure attack and defense, how to provide cloud security, and also how to support security operations and management. And also we're going to look at the Huawei's scenario-specific security solution that Huawei is providing there. Okay. So, and basic cyber security, we're going to understand firewall features, how to configure things like firewall policies, how to configure network address translation policies, also how to configure what you call hot standby. Hot standby is another reliability feature for firewalls. That is where we have multiple firewalls that are doing the same job of providing network security. So to manage these firewalls, then you need to provide what you call hot standby configuration. We're also going to look at how to manage users within a network or rather within a firewall, and also how to provide for intrusion prevention, and also how to provide IPv6 security and endpoint security. Endpoint security is usually ideal for small machines like your workstation, how you can be able to monitor workstations within an enterprise network. Then you're going to look at advanced firewall features, how to configure high availability. You can see it here. Traffic management, like quality of service, or how to configure things like um, bandwidth threshold, how much particular segment can download and upload, things like that. And also intelligent uplink selection. Assuming there are times where a firewall, let me have a diagram. There are times where a firewall, let me have this firewall here, and then I show you what I mean. Assuming you have a firewall here, and this firewall looks like this physically, the small device. Assuming this firewall is connected to two interfaces, or rather to two ISPs. Let me get a annotation tool. So assuming one ISP is connected on that port, that's one ISP, and the other ISP is connected here. Okay, and you're using these two ISPs, ISP1 and ISP2, to provide internet services to your organization network, or that to your enterprise network. So if the bandwidth, or rather maybe the link here, is not that stable, it has so many delays, maybe, or let me use another factor like let me use latency. Let me use latency. Latency is something that we know. So latency here, I would say latency here is 5 milliseconds. And here is 1 millisecond. So you can use this concept we are calling intelligent uplink selection. Intelligent uplink selection to pick the interface that is going to have the smallest latency. Okay. Remember, latency is the time it takes for a packet to get to a destination. So if on this side it's 5 milliseconds, this is a high latency, right? Yeah, latency I said is not supposed to be going beyond 1 millisecond for an stable network. So if it goes up, we can say that let packets be forwarded here, because this other side is having an high latency, right? Yeah, so that's what we call intelligent uplink selection. So that is, the firewall can be able to determine which interface is ideal for forwarding packets. Intelligent uplink selection is another topic that we're going to be looking at here on advanced firewall features, okay, as well as traffic management. Then we have security management and monitoring. We're going to look at how to manage firewalls there and different scenarios. Then we're going to look at VPN technologies, another concept which is also supported by firewalls. Here we're going to look at basic principles of VPN, how to configure the pre-shared key certificate system, how to configure basic applications for various VPN technologies. So we're going to look at how firewalls support IPv6 VPN and also SSL VPN technologies, among others like GRE, that is generic routing and encapsulation. And we're also going to discuss VPN high availability. High availability means that you have support for redundancy for VPN traffic, so that in case one side is faulty, then VPN traffic can be forwarded to a redundant site of the firewall. Then we're going to look at attack defense, how firewalls can be able to mitigate some of the attacks like DDoS, web security protection, content security filtering, and penetration test basics. Then we're going to look at cloud security, how we can provide, how firewalls provide data center networking security. Okay. So remember, when you get here, we're going to merge some of the topics that are covered in data center with the ones that we're going to cover here. And then we're going to look at O&M, that is operations and management for firewalls. Okay, then next is WLAN, wireless local area networking. We're going to look at fundamentals, where we're going to look at CAPWAP tunnel. CAPWAP stands for control and provisioning of wireless access points. And we're going to look at our stations. Stations are like your mobile phone, your laptop, okay? Those devices that are used to access a wireless network, we call them stations here. And then we're going to look at the wireless network architecture, where we're going to look at an architecture called FAT, AP. We're going to look at FIT, AP architecture. We're going to look at agile distributed architecture, okay, and also cloud AP architecture as well. We're going to discuss wireless LAN reliability, where we're going to look at protocols like VRRP. I mentioned about VRRP at some point, where we said we can duplicate the wireless local area network service on different devices in order to provide for backup. So when you talk of backup, we normally have these kind of backups. You have the dual link hot standby backup, and you have the dual link code backup standby, and we have another backup called known as N+1. N+1 is when you have more than one access controller. For instance, let me show you the, oops. So here in this scenario here, we only have two access points. We have these access controllers, this one and this one. Assuming you bring an extra one, a third one, and you connect it to your network, now this is N+1. Okay, yeah. So that in case these two fail completely, then you have another backup access controller serving your network. That's what N1, N+1 backup. Then you have wireless LAN access security. We're going to look at how to authenticate users, how to authenticate the link. Okay, so we're going to look at user access security, link authentication, and also how to block certain users, or maybe whitelist certain users, how to configure station blacklists and whitelists. For example, there are users who come in with special tools that are used for wireless hacking. Maybe you want to tune, maybe you want to modify packets so that you can deceive devices that they're genuine packets that are meant to access certain services. So once you configure these blacklists and whitelists, you can be able to detect some operations and be able to put these MAC addresses on blacklist, so that these users are not going to take advantage of the network resource. Okay. Then we have data security. Data security will okay. So you have data security as well. So we have these protocols that are used for ensuring that you have safe data access to data, and they're generally used for authentication, user authentication. Then we have wireless LAN security and defense. We'll look at some of the technologies that are used now to ensure that our wireless network is stable and secure. And then we have wireless LAN network access control. There we're going to see how users can be able to access wireless networks by implementing things like 802.1x authentication, portal authentication, MAC address authentication, etc., etc. Then we have other technologies like WLAN roaming. Roaming means that you're moving your wireless device, or rather your wireless station, from one access point to another access point without disconnecting the service. So within a wireless network, you can be able to roam. Rather, this device can be able to move from one access point to another access point without disconnecting it, right? Within the coverage, right? Yeah, this is what I'm referring to as roaming, wireless local area network roaming. So we normally have two levels of roaming. We have layer 2 roaming and layer 3 roaming. So we're going to look at those features there. And also we have smart roaming, which is our next generation technology. Then we have the wireless local area network radio resource management. We're going to see how we can be able to adjust radio calibrations, and also station steering and band steering. Okay, and also we can be able to load balance traffic. within multiple access points. Then we're going to look at support for IoT. Remember, we are also in the era where we have to converge, or we are talking of network or rather technology convergence. So we have the Internet of Things convergence. Most access points nowadays come, or especially, let me just speak for Huawei. Let me not speak for other companies for now. Huawei has Huawei has devices that come with AP876. Huawei has indoor access points that support IoT nowadays. All these companies are racing against who is going to produce the best device out there. So you have these products here. If you open this cover here, you press these two buttons, you'll be able to see a small card here, which tells this is the diagram. Once you open this cover, you'll get something like this. So inside here, you will put the IoT card. Most IoT devices have very small frequencies, or rather, their frequencies are not that high in that detecting them will need some specialized technologies inbuilt, or rather provided, so that you can be able to connect them to the internet. So IoT devices are usually used, especially in areas like, where do you find IoT devices? Give me an area where you can have IoT devices. For example, you have a smart lock in your house, right? You have a smart lock in your house that you need to connect through the wireless network there, so that anytime you to be authenticated, it can be able to detect and probably send that signal through the network, rather through the internet. Okay, authentication. So assuming you have these gadgets, so these are IoT. They fall under that category maybe. And other gadgets like which ones? I don't know. You have smart curtains. Nowadays you have smart curtains. I don't know if you've seen those things. Smart curtains where you can open your curtain and close with your phone. Assuming you're an early guy who wakes up very fast and you just get to your car and to get to work, you can automate some of these things, or maybe you can manually control them remotely. Okay, yeah. So these are IoT gadgets that will need to be connected. So Huawei has come up with these access points where you can connect your IoT devices for your smart home. Let me use that word, smart home. I'm sure everyone here is going to have a smart home, or probably you're living in a smart home. Okay, yeah. So we have support for IoT convergence. And then we have wireless positioning. We're going to be looking at planning, wireless planning basics, how to position your wireless access points. These are topic that is common. Ile time utakuwa nasomea wireless, somea hii sana. This one will be very common. Hizi maswali zinakuwa common sana hizi. They don't miss. Wireless planning basics. Okay? Yeah. You can see they have ticked both here. So this one I will teach you on how to design wireless networks, or rather design coverage. Okay? Network coverage. Okay, the spacing between one access point and another access point. So these are the areas that we'll be looking at. And then we have a wireless network planning tool, okay, for cloud campus. So when you talk of cloud campus application for network management, or the network planning, we're going to be using iMaster-NC. iMaster-NC comes with a tool there that we can be able to use for management of our designs, okay? Yeah. So it will tell you what distance you should put from one access point to another access point, stuff like that. Then later, we're going to look at wireless local area network optimization. Here, we're going to be looking at how we can, tools that can be used to improve the user experience. Okay, yeah. So we're going to look at quality of service, traffic management. Okay, so that your wireless network users can be able to access the network seamless. All right, yeah. So those are the topics we're going to be covering. And you have seen, I've just taken you through so that you can be able to understand what is expected of you and how best you can be able to achieve that as you're revising. Okay. I'm going to answer that question. Just give me a minute. All right. So I would like us to start with a few topics. I'd like us to start with a few topics. Allow me to get ready. Okay, let me project. Yeah, yes, there's a good question here. Someone is asking, are we supposed to use this as a template to prepare for the national exams rather? Yes, this is a template you're going to use, okay? Yeah. So questions are going to come from those areas that I've just mentioned. Oops, this one is not coming out the way I wanted it to come. Okay. Let me have it here, then I upload it. Allow me to switch something, just a minute. Just a minute, just hold on. Give me 1 minute. Okay, let me share my screen again. Confirm when you see my screen. Hope you can see my screen.
Yes.
Okay, let's start. Data core. So from now to Wednesday, we're going to be looking at all those topics one by one. So first, we're expected to understand something about VRP. I'll be fast and swift. Someone is asking what time are we closing? What is the best time we can close? 6 or 5? Let's agree. What time we close? Someone saying 6. Remember, I need 6 participants in the regional final. 6. Most voting for 6. Someone saying 5, please. Okay, 5:30. Let's give it 5:30, right? 5:30. Let's do it 5:30. Remember, we have a lot to cover. And I'm sure when you go home for the weekend, some of us will not even come back to it and revise. All right, let's do 5:30. So what is VRP? VRP is a universal operating system platform for all Huawei Datacom products. Okay, so every device from routing, switches, securities, devices like firewalls, wireless, and other devices that are used for optical distribution, which are not covered here, use the VRP, is the operating system. Okay, so it provides a unified user interface for unified management, and it's used now to implement the different functions of a control plane and defines the specifications of the forwarding plane. What are these things they're telling us that we forwarding plane and control plane? Now, control plane is that part of the switch that is used to manage. Let me have an highlighter for you. Highlighter. So control plane here. Oops, I can't write. All right, good. The control plane is that part of the switch or router which is used to implement things like protocol execution. You want to execute a protocol like OSPF, BGP, that is the part of the equipment that is used to run that kind of protocol. Okay? Yeah. And forwarding plane is that part that is used now to send traffic from one device to another through the interfaces. We call it the forwarding plane. Okay? Yeah. We're going to discuss these areas shortly and what their significance. So, VRP. Go and read more about it and understand. Development of VRP. So I'll only mention the things that are relevant, okay, to this competition. Otherwise, if you want to get some in-depth understanding about some of these, you need to go and do that extra work. So I'll be mentioning only two VRP versions that we have. So we have several versions from VRP 1, 2, 3, and the ones that are popular today is VRP 5 and 8, where they might ask you questions about. So VRP 5 is ideal for fixed devices. Fixed. You said fixed devices means the devices was equal to one a box like thing. But for VRP8 is ideal for modular devices. I said we have modular switches, we have modular routers. I've been using those terms. So let me show you a modular firewall. So firewalls usually come in with Huawei USG 9000. Sorry, ISEC engine. There is the word ISEC engine. This one ISEC. I'm just going to use the ones that are new. So you can see this one is modular, right? Modular in nature. So those technologies that we used, we talked about for virtualization also apply here. Okay, yeah, and also modular routers like in 9000. These ones are very new in the market. So I think this one was manufactured in 2022, 2023. Yeah, you don't buy them in Kenya, you'll have to ship one. You can't find any shop that is selling these kind of gadgets. You'll have to ship it. You can see the size compared to the guys who are standing next to it. Yeah. So these ones are used in large data centers. Okay. Yeah, as backbone routers. They provide also virtualization services for supporting cloud infrastructures. Okay. Now for these guys, that's where we find VRP version 8. So in a nutshell, VRP version 8 differs from VRP version 5 in that anytime you type a command in VRP version 5, it is executed immediately. But for VRP8, anytime you type a command, it is not executed immediately until you type another command known as commit. Okay, so how does this one work? For example, like those who have been to an aircraft, maybe you've flown from one place to another, and probably you're planning to be traveling during this competition. Okay, so airplanes. For those who have not seen an airplane, this is an airplane coming through. So aircrafts, for example, this device, these beasts, how they work is that they are given instructions, right? And these instructions don't kick in immediately. Assuming you adjust the attitude of these aircraft, it will not take it immediately. It usually gives you a delay so that in case maybe you decide to change your mind, you can still take it downwards or maybe take to another position. Now that is VRP version 8. You give an instruction, it doesn't take it immediately. It doesn't implement it immediately. It waits until you are sure that you really want this plane to turn and maybe face the other direction. That's VRP version 8. But version 5, the moment you type commands, they take place immediately. The moment you change an IP address, that IP address goes into the equipment directly and starts operating. But for VRP version 8, there's a delay. To give you that delay until you type the command commit. Now, VRP, just like any other operating system, it supports several things. For example, your Android phone, or maybe your iOS phone, has different functions. One of the functions in that phone is file management, right? Yeah, you keep files in that phone. So VRP also has a similar function here, file system management. So here we're going to be managing files. Okay, yeah. So maybe you want to copy files, you want to move files, you want to rename files, you want to delete files. Okay, yeah, you will be copying and pasting, moving, renaming, deleting, right? Yeah, you purchase these devices, they don't just come in with all the features until you get the license installed. Okay, you buy these gadgets, you'll have to install the license. The license is something you go to the Huawei website and download. That website that you normally use for your accessing the academy. The same website utaipata ile time utakuwa unafanya kazi and you need to download a license. Okay, so you go to that website, download the license that you procured, and then you copy it to a flash drive or any other media, or maybe you can use other technologies like TFTP. What is TFTP, someone? TFTP. Yes, TFTP. TFTP stands for. Yes. Answer question so that in case maybe you die with another student and I need to make a decision, I can be able to tell who it was. Yes. Good. Yeah. I want to get used to some names so that let your name appear. All right. Trivial file transfer protocol. Yeah. Trivial file transfer protocol can be used now to send files, okay, from one equipment to another, maybe from your laptop to the device through the management interface. So these devices usually have a management interface, okay? Yeah. Now, what type of files do we find in these Huawei products? One, we have what we call system software, just like your mobile phone or maybe your laptop. System software will be the operating system, right? Yes. So the operating system, VRP itself, will be stored with a .cc. I'm tempted to show you a device from my list of devices here. Let me get a Huawei product. Let me get a Huawei product here very fast. Let me get a Huawei switch so that we can use it for training purposes. Let me pull this one here. Okay, let me get this switch. So if you say this, hope you can see the screen. You say display version. You'll be able to see the version, the VRP version. This is version number what? 5, right? So you can tell the type of equipment that I'm using, right? Yeah, it's not a modular switch. This one is a fixed switch because the version may want to, okay? Yeah. All right. So operating system files like what you're seeing these here are kept using the .cc format. Okay. Yeah. So those ones are .cc. They provide support for management services for a device. The other type of file that we have, or other that we can store on a device, is a configuration file. Okay. A configuration file. Now, configuration files usually have different formats. We have the .cfg, you can see .cfg hapo. Kuna .zip, you can either zip it or you can have the .dat. Okay, so these are the common extensions that you can find. Now, let me get here. I show you some of the files that I have in this equipment. So you can see this one. So this one is probably a what? A configuration file. Okay, yeah. And what is this? The operating system that is in this device. So when you're using an equipment like this, don't delete these files. Otherwise, your equipment won't be able to restart or rather to start. Okay? Yeah, you ensure that you're careful when you're using the device. You don't delete. Don't go and practice there. Practice with ENSP. Then once you've mastered, go to a real device. Then we have patch file. Patch files. Patch files are usually used especially when you want to update the operating system with new features, right? Say, for example, you have a security patch that you've downloaded. Maybe Huawei has announced that you need to download this patch and install it in your devices so that you can fix some bugs in the operating system. Okay, so this will be .pat. Then we have PAF files. Now, what are PAF files? PAF files are files that have things like name of the equipment, or maybe logo. Sometimes the Huawei logo has gone through some transitions, just changed over time. That is something I can tell you. The Huawei logo. There's a time I was wearing a polo t-shirt and I was told by someone that this logo is ilipitwa na wakati. So I didn't know. Well, these logos don't look any different. They kind of resemble, but actually different. Okay? They changed the logo. Example ilikuwa black, I don't know, want to believe. So to update your devices with the current Huawei logo, Then you need path files. Okay, yeah, done. We are done there. The other part that, or the other function of an operating system, that is the VRP operating system, is management of storage. Management of storage. That's where we're going to look at. So we have different storage media types. We have NVRAM. NVRAM is a non-volatile random access memory. Well, this one is not used to keep files like your configuration, but it's used for logs only. We only use it for keeping log files. So what are logs? Logs, these are files that are kept that describe the activities that have taken place on an equipment over time. Okay, so we keep an NVRAM, or rather NVRAM is a non-volatile. Non-volatile means that it does not delete the contents if there is an electric cycle or a power cycle on the equipment. Power cycle meaning stima zimepotea na zikarudi. We have another non-volatile memory known as flash. Flash ni kama hard disk drive ya laptop. Okay? Yeah, so this is where we keep all the files. For instance, here, sorry, I will display the wrong thing. Here, I hope you can see this part. Let me minimize this so that you can see. So here we have the files that are in the flash. You can see this command here. So I said dir flash. Then I press the enter key. So it will show you the contents that are in the non-volatile memory that we're calling flash memory. So when you're buying a switch, these are some of the things that you check. What is the flash memory? You display version, it will show you some of these features it has. So when you're buying a switch, useme tu nataka switch iko na 24 ports, right? You also say that I also want the DDR. You can see DDR, 2 GB, flash total is that. Okay, depending on the type of equipment you're using. Okay, yeah. So the other equipment that have higher memory. So when you're buying an equipment, you also check for this. Usigongwe. Sema tunataka switch. Kuna switch niliona inaitwa hivi, right? You also put specifications, just like you buy a laptop. Okay, you also specify how much storage, how much memory processing power as well. Then you have SDRAM. SDRAM is stands for synchronous dynamic random access memory. So this one is equivalent to the computer's memory, main memory. This one is volatile. Okay. In other words, if you are doing configurations on this on an equipment and you forget to save, okay, yeah, you are doing some configurations and you forget to save. How do we save on our Huawei equipment? How do we save? We type the save command. If you don't save, for instance, you have done some configurations and you've forgotten to save, and this device goes through a power cycle, that is stima ipote, then what is in the SDRAM will disappear. Sorry. Then we have other external devices. These are peripheral storage devices. These ones are peripheral. For instance, you can connect an SD card or a USB drive. I'm sure most of you know these ones. If you have never come across SD cards or USB drives, you can check that on the internet. Then we have device management. How do you manage devices using the VRP? In other words, how do we access the human-computer interaction with our devices? So we access devices using either web interface or using a CLI. Okay. For instance, I've shown you how to access the device using a CLI. For instance, this is CLI. I'm also going to show you. Let me show you with another device here. CLI, sorry, graphical user interface. Let me use a Huawei access controller that I have for purposes of demonstration. We have HTTPS 192.168. Let me show you a controller. So this is a Huawei controller. This one here. I hope you can see it. It's a wireless LAN controller. I'm going to show it. It's what we call the what do you call it? We call it Huawei SC6508. Now, Kanakai, okay? Just like a small gadget, but it's very powerful. It can support 4,000 users. Right, so, oh, sorry, I just switched off. Let me log in so that you can see the comments here. Let me log in. Let me log in, then I bring it back. Okay. All right, it's coming up. There it is. Now, these are graphical user interface. Okay. For managing different services, you can see attack, defense. These are for security. These are for WLAN, right? Those things we're talking about. Reliability, okay, VRP, VFD. You want to configure it for that, you enable all these here. Quality of service, you can create a policy and bind it to different virtual access points, okay. Station identification, you can also implement all these things as well, okay. Yeah, and then turn on some of these settings. In other words, it's used for managing your, assuming I want to manage like APs going online. These are my APs here. I have some at my office here, as others elsewhere. Okay, that is web interface. I use the web interface to access the graphical user interface. So we use HTTPS, and some other brands also use HTTP, which is not safe. You know the difference, I believe. Yeah. Then we have the CLI. Now, how to access CLI? CLI, we use a console cable. Let me show you what is a console cable for those who have not come across some of these. The console cable. To access that, you use a console. Unfortunately, I'm not going to be able to explain everything that we have out there, but I'm going to try my best. So this is a console cable. Where do we fit this thing? Or rather, how do we connect it? So this side looks like an RJ45 connector. I'm sure everyone has seen an RJ connector and stuff like that. And then you connect it to your devices. Let me pick a device of choice here. So on this switch here, I hope you can see clearly here. So these are console ports. This is where you connect it, okay? Then once you connect it to your laptop, then you need what you call a terminal emulator. Let me show you what a terminal emulator is. A terminal emulator is something like what you can see here. I'm using something called MOBAX stamp. MOBAX stamp. MOBAX, you can search it, MOBAX. MOBA stamp. Some people call it MOBA stamp. So I use this one for accessing your device. So to access a device, I usually use this session. Then you have the different protocols for accessing devices remotely, and we are going to discuss them. Then we have serial here. Then under serial, this will be your meaning that you want to use a console cable. It's called a serial cable in another world. So there are things that are important here. Let me just highlight them for you. Speed should be 9600 beats per second. It's beats per second. Then data bits inafaa kuwa 8, stop bits inafaa kuwa 1, parity none, flow control none. So these are the things that might be asked. I hope you take screenshots. You can take a screenshot and keep it somewhere. So they will test whether it should be 900, 600 beats per second, 8 bits, 1 stop bit, no parity, checking, and no flow control. So once you click OK here, it opens now the CLI of that equipment, and you can be able to log in and manage the equipment. That's it. Any questions there? Then now, so I say you can use a console cable. So this I would say use a console. Now there are times where you don't need to use the console because it can be cumbersome. In other words, you are seeing everywhere working with a console cable, just trying to look smart and tough. You can actually access these devices remotely. Now to access these devices remotely, now that's where VTY comes in. Okay, yeah. VTY comes in now to help you connect to these devices remotely. Remote. What do I mean by remotely? I'm seated in my office right here, and I want to access a device that is at Chiromo campus in Nairobi, or maybe at Kenneth offices in Nairobi. We have some co-located services there, and I want to access it while I'm seated here. Okay. Yes, assuming now I'm logging to that. For example, I'm going to use something. Let me use an example. So I type maybe a public IP 165.23.1.5. Well, this one does not exist. I don't know whether it exists. People don't say ameachilia huku hivi machine yake. Okay, nobody has left it. I'm just trying to show you, like, okay. So assuming you have a public IP 189.25.1.5. So use SSH, for example, SSH to access to your device. Or you can also use Telnet, but Telnet is not safe. Why? The packets that are sent using Telnet are usually in plain text. What does that mean? In other words, someone with an intelligent tool can be able to see the type of data that is passing through there. Assuming you have an intelligent tool like, let me see that I have some intelligent tools here. I'm doubting that I have something. Assuming you have, I don't know what that means, an intelligent tool. Assuming you have some packet capture kind of tool. That comes with a tool that you can use to capture packets. Let me use this interface here to capture raw packets. So assuming you have an intelligent tool that is able to capture communication that is taking place between two devices. For example, I can see we have a communication between these two devices here, 192.168. Let me zoom. Sorry, it can't zoom. Unfortunately, sorry. I'm just showing an example. So the type of traffic is encrypted. You can see it's encrypted. But now for Telnet, if you have to use Telnet and someone finds this kind of tool, they can be able to pick these passwords there. Okay, you can be able to see passwords in between the text that is being exchanged between these two devices. Are we together? Yeah. So we don't use Telnet for mission critical areas or other sensitive areas of our network. We use SSH, secure shell. Why? Because traffic is going to be encrypted. The packets are going to be encrypted. So now to configure SSH and Telnet, now you need to understand something about VTY user interfaces. Okay, yeah. Go and read about that, okay? Now let's look at VRP user levels. So once you configure, say for example, user access control on your device. Maybe it's a switch, is a router, it's a firewall. Once you configure user access control, then you need to specify the level of control. Different users within your network will need different levels. So you have the least you can have is 0. It's called visit level. Then 1, the monitor level. In other words, you cannot type advanced commands here. You'll just view, okay? Yeah. Then now we have 2, which is configuration level. You can configure some level of configurations, but not advanced configuration like protocols, right? But 3 to 5 is where you can configure the management level kind of aspect, or the level of configurations, or the configs. Okay, and also delete files there. Okay, in that equipment, right? Yeah, so you need to understand these levels. So we have discussed about this one. Now let's look at basic command structure. Commands usually start with a command word, followed by a keyword, and then the parameter list. Say, for example, you want to select an interface. So use the command interface, which is the command word, followed by keyword gigabit Ethernet 0, and then followed by 0/0/0, which is the parameters. Okay, yeah. Assuming this command here says display IP interface gigabit Ethernet 0/0/0. So this one is going to display the configurations on that interface. Another example, say for example, you're told to reboot a switch, or rather to restart a switch. Use this command. So this is the command word, reboot. We use it when you are rebooting a switch. Now, let's have an overview of the campus network. So a campus network is usually a local area network that connects people and things in a specified area. Typically, a campus network has only one management entity. Okay, yeah. So a campus can be a branch, maybe your organization, branch your bank, okay, branch your university, okay, or other campuses that are outside the HQ, or rather the main campus. No, campus is not used as, to refer to a university network. Okay, yeah, we use it to refer to a network that is within a manageable area. Okay, a remote user can also be working outside campus network. Say, for example, you want to configure working from home. You want to enable your staff, or rather your employees, your users, to access your network from home using an SSL VPN. Okay, yeah. Or you want to connect your network to a private or public cloud, right? Yeah. So what is found within a campus network? A campus network will find things like a demilitarized zone. What is a demilitarized zone? This is a zone within your network where users are not supposed to access directly unless authorized. Okay. Yeah. Say, for example, you put your servers there, or maybe your ARTBIT links. There's something called an ARTBIT link in the network, so it can also fall under the militarized zone. That is, user traffic is not supposed to interact there with that area directly. Okay, yeah. Or maybe you have your data center there, or maybe network manager. Remember, we say network management is that area within your network that is used for monitoring and also enabling the full life cycle of network development. Then we have something called the egress layer of your network, of your campus network. This is the network. This is a part of the network that connects to the ISP, rather connects to the external part of your network. The next to it, we can have the core layer, which is high speed layer, or rather high speed transmission layer, where we connect powerful switches to aggregation switches for high speed forwarding. An aggregation layer is a layer where we connect other smaller switches that we call access switches together for purposes of forwarding to a core layer. For instance, assuming you have a building floor, I'm sure most of you have gone for attachment somewhere. Story. Oh, sorry. Let me get. I'm just looking for a building in one for that effort. Assuming, I don't know, I've never seen the infrastructure here. Everyone knows this building. Assuming in each floor, you have floor switches. We call them floor switches. A floor switch is a switch that will be used now to connect the users of that particular floor. Okay, or maybe let me use Times Tower. Okay, yeah. I don't know, Times Tower is housing KRA and which other organization, or maybe just KRA, I don't know. Maybe KRA and another organization is also housed there. So the floors here can be connected with different switches, okay? Yeah, and then we can have an aggregation switch. Okay, that connects now all these floor switches together for purposes of forwarding to an upper layer core switch. I'm going to show you a logical diagram. Then we have access layer. Access layer is the layer that connects the user terminals. This is where we connect our devices like our computers. This is also where we connect our wireless access points. This is the Wi-Fi. This is where you connect the devices on the access layer switches. Then you have the terminal layer. Terminal layer, this is where we find your devices, your workstations, your wireless access controllers, your IoT devices. Okay, yeah, like things like door access systems. Nowadays we have sound systems that are connected on the internet. I don't know whether you come across that one. It was in somewhere where I saw like nowadays you can connect sound systems to the internet. I saw speakers that have been connected with Ethernet cables. That was my first time seeing one. So this is an access switch, for instance. So the ports here are actually mostly copper. Okay. Yeah, they're actually copper and they usually are connected with an RJ45. How? RJ45. This kind of connector, yeah. You've seen those cables, yes. That is the access layer. Okay. Now, this is a typical design of a campus network. All those things that I was mentioning. So within a campus network, you can have a branch connected to it. Okay. You can also have a data center connected to it. A branch will be connected externally through the internet. Okay. So here we can set up maybe an MPLS IP or rather BGP MPLS IP VPN, or you can just have an IPsec VPN from the branch router or maybe the branch firewall to the campus or rather to the headquarters firewall. You can set an IP security VPN to ensure that you can access the branch securely. Okay. Yeah. Now, within the network, the campus network, you'll also need to have what you call the network management zone. What is this zone? This is where you deploy servers which run network monitoring and management softwares. I showed you something like this. So where this service is running is on this management or the network management zone. So for instance, you can have iMaster NCE campus running there. Okay. Yeah, if you want to see the full life cycle of network development, go and ask your organization that you'll be working for to buy iMaster NCE. It's one of the products that I've seen that is really doing well out there compared to the Cisco SCI. Where Cisco SCI is still okay. Right? For me, I find iMaster NCE looking good. All right, then we have other areas like core. So this is where you deploy your core switch. Okay, this is where you deploy your core switch. Now, a core switch is a switch that has, let me show you what it is. A core switch will be something like, say, Huawei S8500-6. Sorry, not that one. Sorry. This kind of switch. So, I don't know why it is bringing this Huawei phone. Sorry, not 85, it's 8700. Sorry, that's why it's giving me this wrong information. 8700. So, for instance, this is what I use here. So, this can be a core switch. It provides high-speed forwarding and high-speed data switching. Okay, yeah, they're usually modular in nature. They are very powerful. They can support large bandwidth. For example, like the one I have as 100 gig ports. Okay, yeah, so if you want to test 100 gig, you can get that on a card. Let me show you the cards. So the cards, let me see whether I have something. I'm not showing. I'll show you in another forum, maybe as we continue next week. Yeah, so you purchase those cards and then your aggregation switches. So your aggregation switches, you connect them to this switch here for high-speed transmission. Well, I'm not going to tell you that, I'm not going to ask you to go and tell that organization you will be working for to purchase that kind of a switch. You look at the demand for the resources that or the internet resource within that organization. How large is that network? There's some network that will require a very tiny switch, for example, like a 5720 switch, and that's it, and they will be comfortable. The others networks that will need a D-Link 8 port. Assuming you are to start, or maybe you set up your own office, a small office, maybe where you can be serving your clients, okay, as a beginner. So you don't need to go for that big daddy that I showed you. You just need to buy this one. This one goes for around, this one is too expensive. I need something like TP-Link. So if it's a small network, we just need these gadgets. So this one go for like 500 shillings, 1,000 shillings, okay? Yeah, and it will still be your core switch. So based on the size of the campus network, now you need to determine what type of switch you need, a particular layer. Aggregation switches, now these are switches that are used to connect access switches, okay? Yeah, we call them aggregation switches. Then we have said access switches are used to connect workstations and also connect printers. We also connect wireless access points to these type of switches as well. Let's look at network devices. So I've said we have various network devices. We have access controllers. These ones are used to provide wireless local area network services. Now, an aggregation switch will have this sign. I'm just showing this symbol so that you will get used to the diagrams that we're going to use. So this is an aggregation switch.